Hello everyone. So in this media we are going to discuss about IG alarms and trip. I had a couple of queries regarding this, and this is the most favorite question of the surveyor, and it is very important also. We all have been working on tankers and there, so we are very much familiar with the IG inert gas system. So before we proceed on to the alarms, not only the alarms, the shutdowns or the trips. So here we have what is known as A. We have categorized these alarms in the categories of A, that is alarm, that is instantaneous stop. Wherever you find B, that is alarm stop. C is alarm, D is alarm, E is alarm, F is alarm. So alarm, that means if that is total stop. E, blocking of cargo pump when tank pressure P is less than 100 mm of water gauge. Okay, these alarm, that is audible and visual alarm only. Atmosphere valve open, consumer valve closed. B. Alarm stop all automatic valve except seawater valve to shut down position. Stop of oil pumps and blowers. Okay. A is alarm instantaneous stop. All automatic valve to shut down position. Okay. So now what we have been discussing. See, this is what I was telling you about. See that we have categorized all these alarms and trips in the group, and this is FAAA. So I have discussed the terms what is related to it. Okay, so now when we discuss about, it's the first alarm that comes is power failure. Okay, so that is in group F. And then we have emergency stop, which is group A. High seawater level in scrubber, so we have a scrubber tower. Okay, so that we, if we have high seawater level, now we have high seawater level in cooling water and cooling tower generator, low instrument air supply pressure, blower failure. See, now we can have two category of IG, from the boiler uptake or from the blower itself, that is from the atmosphere. So generally tankers with high pressure boiler, oil tankers specifically, they will have this from the boiler uptake. So from the boiler uptake they are generating this inert gas system through all the process of scrubber and of everything. Now what is prevalent and most important is the, and there you have topping up generator. Okay, so we also have IG generator, that is known as topping up generator. Okay, now in other tankers like gas carriers and all, so there you will have the blower from, not from the boiler uptake. Okay, so low combustion air pressure, high combustion air pressure, low combustion air pressure, high IG temperature. So the IG temperature, if it goes high, so high IG temperature in scrubber, high seawater temperature in cooling jacket, flame failure. Flame failure is very prevalent and most important. Low fuel oil supply pressure to burner, low seawater supply pressure to scrubber, low seawater supply pressure to cooling. Okay, so now see, this is topping up generator. Okay, now this, see, whatever we have discussed, these alarms may not be prevalent in all the type of IG plant that you have on board, because if you are an oil tanker, so that if it is taking from the boiler uptake and all, so there is no point of having a flame failure alarm. Okay, so now where we have IG generator, where we are supplying the fuel oil, that is DO, and then we are burning it in the generator and then passing it through the scrubber and all. So there you will have this flame failure, which is important. So you have to be very decisive in pointing out the alarms. It's not, it's a generic list. Low fuel oil supply pressure to burner, low seawater supply pressure to scrubber, low seawater supply pressure to cooling, the low seawater supply pressure to, and now low seawater level in the reservoir. Okay, so we have in the reservoir, that is low seawater level. So this is what I didn't discuss is deck water seal. We already have covered about the seal, that we have, what are different types of seal that we have, and that is dry seal, okay, and wet seal and all these things. So we have discussed all these deck water seal and all, and what is the importance of deck water seal and why it is there. So all these things, low seawater level in deck water seal reservoir, high gas pressure in main inert gas line, low gas pressure in main inert gas line, low pressure in main inert gas line, high low oxygen content. So this is again the flame failure part and this high low oxygen content. So sometimes in older ships and also you have to continuously monitor and continuously adjust. Okay, so low value will be less than 1%. It cannot be less than 1%, and high value that cannot be greater than 5%. Now, when we speak about this oxygen content, why it is important is because of the flammability diagram. So, if you are not aware of it, we already have covered in one video. You can refer in my videos about the flammability diagram. So, what is the 8% and 5%, and what is the rich to lean to rich to thin mixture and all those things. So we have covered all these things. So from there you get this 5% and 1% mark. Okay, now start sequence is blocked if alarm 1 activated prior to start. If inert gas main valve is closed, it will not be possible to select inert gas to consumer upon alarm. Okay, so these are the generic list of, there may be some other alarms as well based on the modernization that is taking place in shipping industry. So that's all from my end. All the very best. Thank you so much.